A famous mathematician is one of n people on a bus one morning. At each stop, he notices that x people get onto the bus, where x is greater than 2, and one person gets off the bus. After 5 stops, there are now x times the number of people that were on the bus before the first stop. How many passengers were on the bus before the first stop? And how many passengers got on at each stop? Our first step to solving this problem should be illustrating exactly what's going on with a diagram. So let's put some of this information into a picture. We start off then with n passengers on our bus. So over here we've got an n. Our bus makes 5 stops, and at each stop we have x people getting on and 1 person getting off. So I'm going to represent this with 5 arrows. 2, 3, 4 and 5. And our x people getting on and 1 person getting off, I'm going to write a plus x for each stop, plus x, plus x, plus x, plus x, and we get 1 person off at each stop. So that's take away 1, take away 1, take away 1, take away 1, take away 1. So our overall change at each stop is plus x minus 1. Well, at the end of our 5 stops, we now have nx people on our bus. So that gives us an nx over here. At this point, we're ready to take this picture of what's happening on our bus and turn it into some algebra. So let's look at what this means for us. We start off with n people. So there's n people on my bus at first. And what I've done is added on 5 lots of plus x minus 1. So we need to add 5 lots of x minus 1. Well, what we end up with is nx people on our bus. So over here, we're saying this is all equal to nx. This is nice because we've turned our picture into an equation which hopefully we can work with. What we'd like to find is n and x. So there's 2 ways we could approach this. I would like to make x the subject. So first of all, we should expand out our brackets. So here we're going to have n plus 5x, take away 5, equals nx. We've expanded our brackets on the left-hand side. And now continuing on, we'd like to get all the x's on the same side. So on our left-hand side here, we're going to be left with n take away 5. And on our right-hand side, we're going to get nx take away 5x. Well, now we should be thinking about factorising. We've got all our x's on the same side, but we can take out a factor of x therefore. So we've got n take away 5 equals taking out our factor of x. Will leave us with our brackets, and there'll be n minus 5 in those brackets. Okay. Well, this is a nice place to think, oh, we're almost there, isn't it? N minus 5 equals x brackets n minus 5. Obviously, what we should do now is just divide through by this n minus 5. So let's divide through. We've got n minus 5 divided by n minus 5, over there, equals x. And then clearly here, we can just cancel out. These both cancel out to leave us with 1 equals x. Job done, we're happy, aren't we? Our x was 1. But there is a problem here. And we got told explicitly at the start of the problem, x must be greater than or equal to 2. So our answer of x equals 1 just doesn't work. What we need to do now then is think, why does this not work? What have we done wrong and how can we fix it? And you could take a look here and maybe put in the comments, where was our mistake? But if we look back up a couple of lines, we will see it. It actually is on this line here that we've made our mistake. So I'm going to put a nice line underneath this line. And we need to think about the ways that we could interpret this line. So we're going to move over here. If n minus 5 equals x multiplied by n minus 5, well, there are two conclusions that this could give us. We could either have number 1, our first conclusion that this could give us is x could be 1. So we could have n minus 5 equals x n minus 5, implying that x equals 1. That only works if we're allowed to cancel out these n minus 5s. And thinking about that as a division, well, there's one number that we are definitely not allowed on the bottom of a fraction. And that's 0, isn't it? We can never divide by 0. So I'm going to write here, cannot be 0. The number on the bottom of our fraction cannot be 0. What that means for us then is that this is the key to our mistake that we made. We divided through by n minus 5, that cannot be 0. But because something broke in our problem, this must have been 0. Let's look at what happens if this was 0. Because this answer here, x equals 1, is clearly not right. I'm going to put that x in a circle as in, no, we cannot do that. Looking at our second option, if we've got n take away 5 equals x multiplied by n take away 5, well, this could be, in the case that this was 0, we could have 0 equals x multiplied by 0. This is obviously true. And it's true not just for one value of x, but for all values of x. So what this would mean for us, in the case that we had 0 as our n minus 5, this would mean n equals 5, and actually x could be any number. So x, we're told it was greater than or equal to 2, so let's just stick with that. X is greater than or equal to 2, but we can't say any more about x. It could actually be any number that we like. So we're adding that on and underlining these two. So the answer to our problem was that the number of people on the bus to start off with had to be 5, and x can be any number greater than or equal to 2. That's actually really cool. It doesn't matter how many people were getting on our bus at each stop, this still works.